Hey everybody, Gabe Jenkins back with you in a really interesting, fun thing that we're about to move off into. We have spent the last month and a half, roughly, maybe more than that now, designing SolidWorks parts and learning how to do both SolidWorks parts and how to do SolidWorks drawings that represent exactly the dimensions of each and every one of those parts that we made, right, from different angles. So we know that SolidWorks is really an effective software program for designing three-dimensional CAD parts. We also know it's really good at representing all of the dimensions and the different angles and the views, section views, etc. of that part if we wanted to show that part to somebody else in a manufacturing context. What we're going to move on to next is maybe the most fun part of SolidWorks entirely, which is something called assemblies. So, when you're designing things for the real world, you want to know how each part fits and interacts with every other part. And of course, you could manufacture parts separately in the real world, either with a 3D printer, additive manufacturing, or you could mill it out or use a lathe to turn it out. Somehow you could make your parts and then in the real world put those parts together and see if they fit together, etc., see how they interact with each other. But obviously that's kind of a risky move, because what if they don't fit together? Right? It'd be really, really beneficial to see how parts fit together in a software package, so that we could actually just simulate what they look like and how they're going to interact. And what assemblies allow us to do is they allow us to take different parts that we've created and assemble them together to see how they work. So what you see right here is an assembly. This actual assembly is something that is like a mill, a table of a mill. So just like we have in our CNC room down the hall, this is it's a base of a CNC mill, or maybe just a manual mill. And in a mill, right, this part here can move back and forth, or forward and backwards, can move left to right on the x-axis, back and forth on the y-axis. And this is actually a very simplistic model of what a mill table would look like. But you see here, it is made up of multiple components. So just to help you orient yourself to what you're looking at here, what you have here is an assembly of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different parts. Okay, if we zoom in on any of these things, right, we can see like the clamp, right, the pins, clamps, pins, etc. And the knee is at the bottom, the saddle's here, right? So all these different parts. And so we've imported these parts. All these parts were designed separately, and we've now imported, we inserted these component parts into an assembly. And the next thing that assemblies allow us to do is they ask us to figure out how to join one part to another. How to mate them is the word that SolidWorks uses. How to define how those parts are expected to attach to each other, interact with each other, how to position them with respect to each other. Just real quick, just so you see this, the very first part that was imported in here was the knee, and you see an F right next to it. That means that it is, when you first imported it in, when I first inserted it in, the first thing you insert into an assembly is fixed in the assembly space, right? It's just fixed. Everything else you subsequently insert into there can float around. It can float in all 3 axes. You can also rotate it so that it's spun around however you want it to rotate around. But those are floating around. They're floating around, which is indicated by the little, if I expand this here, you can see all of these are the different parts. But it is the fact that it's floating means it will not have an F next to it, right? So it's able to be moved in that space. So all of these are different parts that I have imported in here, but not only do I have all these parts in here, I've also got all of the different mating relationships between one part and another. So I get to define how each part is attached to every other part, and I can find all of that under mates. So if I expand this, actually, just before I do that, the part history, just like you've been working on for each part, it's all preserved within the assembly, right? So like it shows you how each part was made, what was the sketch, what was the extrusion. You can look inside each one of those things if you wanted to. If you wanted to look inside the sketch and edit the sketch, you absolutely could do that with every single part, right? I'm not going to have you do that because theoretically you've already adjusted all those things, right? Cool. All right, but we got all the parts along with all of their histories. Everything is in there. And we've also defined how we want each one of those things to be related to other parts. That can be found here under mates. And so for each one of these things, coincident, distance, concentric, they're all different ways that different parts can be related to a different part inside the assembly. And there are some that are very simple, like I want this face to be touching this face, and I want them to be coincident, right? Really simple. It can be like I have this circle and I want this other circle to have the same center point. So I want them to be concentric, right? Those are different simple mating relationships, but different mating relationships can be very complicated. You can have different gearing ratios stuck in there. So it's like if this gear is bigger than this gear, but they're expected to turn one turns, the other one turns the other in a different direction. You can define how you want the gearing ratios to be. So they get much more complicated than just I want this part to touch this part, but that's where we're going to start, right? Like I want this part of this piece to touch this part of that piece. And ultimately, what you're really looking to do is you're looking to attach piece parts, angles, sides, facets, lines, edges. You're trying to figure out how to join one part to another that defines exactly where they are and how much freedom of movement you want them to have. So if I look at really quickly, this part right here is attached to here. So if I look at like, let's just look. So the knee and the saddle are attached to each other, and there's different faces in here that are attached to each other. I allowed them some degree of movement. So I'm allowing it to move back and forth only in this. If I try to move left and right, it's not going to, but it will allow it to move backwards and forwards. This piece is attached to the saddle, and the only way this one can move is to go left and right, but it cannot go any other way, right? So you're trying to decide exactly how to define how each part is related to another part so that they all fit together exactly the way you want them to do and have whatever degree of freedom of movement you want those parts to have. And if you define it correctly, you're going to end up with an assembly that really, really accurately depicts what you want to see in your finished product, with every part linked up with every other part in a way that really is a realistic portrayal of what you want the final finished good to be. In terms of any other information, we're going to get into this in the next video where we walk through how to start creating one. But just so you see this real quickly, when you go up here to new, we know how to make a new part, and we know how to make a new drawing. If we wanted to make an assembly, we can start by making a new assembly and then starting to import the components. If we already had a part open and we just wanted to use that as our starting part, we could just say, okay, make an assembly, and it'll start to create an assembly using that first part that we had open as our starting point. Big picture things here. Every time you want to insert something new into your assembly, you would go to Insert Components, and you could find your file that you're trying to insert. And then secondly, Mate. If you want to start like linking up one part with another, Mate is the button that helps you to do that. All right. So that's where we are. That's how we start off in assemblies. And then the next assignment is going to have us start to make a very simple assembly to start off with. All right, everybody. Good luck to you.